Hey guys, so in this video, we're gonna discuss Leetcode 426, where we're gonna convert a binary search tree into a sorted doubly linked list. So a binary search tree is a tree that every node will have a maximum of two children, the left one and the right one. And the left child will always have a smaller value, and the right child will always have a larger value. And for this problem, we want to do the transformation in place. And after the transformation, the left child will point to the previous node, and the right child will point to the next node. So the left one will point to the value with the node with a smaller value, and the right one will point to the node with a larger value. And we need to return the pointer to the smallest node in the linked list. So for example, in example one, for this binary search tree, we're gonna return like 1, 2, 3, 4, 5, where node 1 will point to the left, the right pointer will point to node 2, and the left pointer will point to node 5. And same for node 2. The node 2, the right one will point to node 3, and the left one will go to node 1. So this is what we wanna return. So in this problem, the algorithm we're gonna use is like for binary search tree, we're gonna whenever we wanna give them the sorted nodes, we have to use a stack to process the binary search tree. So this is what we're gonna use. So basically, we're gonna have a stack to store all the nodes in a binary search tree, and then keep going to the left until we reach the smallest node. And then we process the smallest node. Once we finish processing it, we pop it from the stack, and then we can get the second smallest node, which is the parent of the node 1. So we process the parent, the node 2. And once we finish process it, we check if it has any right child or not. If it does, then we process the right child, which is the third smallest value. And once we finish processing it, we're gonna check if it has a left child or right child or not. If it doesn't, then we pop from the stack again, so which will be the fourth smallest value of the node, and then we keep processing that until we reach the end of until we finish processing all the nodes in the binary search tree. So we're gonna use this algorithm, and then during the processing of each node, we just keep linking the nodes with the left and the right pointers to make them a doubly linked list. So this is what we're gonna do. So let's get started. So in the very beginning, we're gonna consider an edge case. Like if the root doesn't exist, then we just return null. So if not root, we return null. This is just an edge case. So now we're gonna just code out the algorithm that I just described, that we process a binary search tree, like process the nodes in order. So we're gonna use a stack for that. So the stack. Okay, let me code out the algorithm first. So this algorithm is like while true. So what we're gonna do is like if the root exists, then we just keep pushing the root into the stack. And then we just go to the left node, keep going to the left node, root equals root dot left. Otherwise, left. Otherwise, just pop from the stack. So current root node, we stack dot pop, just pop from the stack. And we're gonna process the node. So this is where we're gonna current node. All right, and then root will equal to current node dot right. We just check if it has any any right node or not. Then we process the right node. Otherwise, we break. So let's take a review on this on this algorithm. So basically what we do is like, if the root node exists, like here, then we append it into a stack and then keep appending the left child into a stack. So we append the node 2 and then we append node 1 to the stack. And then it will be it was there's no left node, right? So we process this value, this node 1, which is will be for sure like the smallest value in the binary search tree. And then once we finish processing it, we check if it has any right child. In this case, no. So we process the second one. We just keep popping out from the stack. So we process the second one and then check if there's any right child. Then it does. So we processing the third smallest value, node 3. And then like if it doesn't have any children, that doesn't have either like left one or right one, right? So we're gonna just keep popping from the stack. So we process node 4. And then we just check the right child, which is node 5, and processing that. And then it doesn't have any child. Like when we process like root left or root right, that doesn't have any value. So we stop. So we don't process anything. So we stop from here. So basically like we process node 1, 2, 3, 4, 5 in order. So this is what we do here. So now we have sorted out the algorithm to process the nodes with values in order. Then we need to figure out how to turn them into a circularly doubly linked list. So basically we need a dummy head to have a root node. So let's just say have dummy head equal to node, make it none. And then let's say head equals let me just do this one. We need a dummy head, right? So now we just need to process, when we process the current node, we just use a dummy head to process them. So let's say dummy head, Command C. So the right one will equal to the current node. The right will equal to the current node, and the current node dot left will equal to the dummy head. And then we can just move the head. So basically what we are doing here, so it's like we have a dummy head, so we are pointing to the node 1, right? So we just like pointing to the left one to node 1, and the node 1 on the right is the dummy head. And then we just move when we go to node 2, we just need to point at node 1, like the right is node 2, and the node 2 right is node 1, right? So we just move the dummy head to dummy head equals dummy head dot right. So we just moving. So we process dummy head and then we move dummy head to the current node, so that when we are processing node 2, we can just link the node 1 to node 2. So this is how we do that. So and then in the end, we need to link like node 1 and node 5, right? So we need to keep track of the latest node. So we need another variable. Last node will equal to the current node. So this so that we can keep track of the current node, and then we need another head that equals to dummy head. So we keep a track of. Oh, sorry. So we keep track of the last node here, last node, and then the head node. Let me just call it head node, so that like the head node is always pointing to this one. We never change that, and the last node is like we keep changing until we reach the last node. And now we need to link the head node, like the first node to the last node. So the first node will be the head node, the right pointer, the right on the head node. So we just need to, lastly, we just need to link the right. So let me just comment here. Link the right of the head node, which will be the first node to last node. All right, so what we can do is here. So first node to head node, right? And then, so we just need to link the first node to the last node. Let's see, first dot should be left to last node. The last node, right, or equal to the first node. Yeah. Why there's a right line here? Let me see. See how it goes. Yeah, looks good. Yeah, it works. I don't know why it has some warnings here. So yeah, so basically, like we use a stack to keep a record of all the left nodes of the binary search tree, so that we can process the binary search tree in order from the smallest value to the largest value, and then we just use a dummy head to keep track of the to use a dummy head to keep track of the current node, so that it can doubly link the to the while we're processing every node in the stack, we can just doubly link to the node, and then like and convert it into a doubly linked tree, linked list. So basically, this is the code for this algorithm, and yeah, so time and space for both of them should be order of n, which n is the number of nodes in the binary search tree, and yeah. So this is the end of the video, and I'll see you guys in the next one.